In this video, we're going to learn how to write rules for sequences. This is the follow-up video to the sequences video. All right, so let's start off with a sequence. Let's say the sequence is sequence T, and actually sequences are usually capitalized. I'm not sure why, but sequence T is 30, 25, 20. I want you to fill in the next three numbers when you copy it down, please. How is this pattern growing? All right, and then what type of sequence is this? Hopefully you agree that this is an arithmetic sequence because it's linear. If we graphed this, it would make a straight line, and it's growing by adding or subtracting. So now there's two different types of rules that we can write for sequences. We can write explicit rules, and we can write recursive rules. Now, explicit rules are the type that you're used to. It's where if I give you this rule and I tell you what's the 100th term, you could just plug in 100 and figure out what the term is. A recursive rule is one where it just tells you how it grows, but it depends on itself as it goes. So it's not as useful for finding something really far away, but it can help you if it's a tricky situation where you don't know another way to write it. So let's actually start with the recursive rule for this one. Okay, so a recursive rule always has two parts. You have to know one of the terms, and you have to know its growth pattern. So you have to know one term and how it generates the next term from the previous one. So often you're given the first term, but it doesn't have to be. You could give any of the terms. All right, so for this one, the one term part would be to say that T, I keep doing a lowercase t, that T of 1, so that would be the first term, is 30. And then you would say that how we generate the next term, so T of n, so how you get the next term would be T of n minus 1 and then minus 5. Because hopefully you agree that what we were doing here is we were subtracting 5 each time. 15, 10, 5, like so. And so what this means right here is the term, and this right here is the previous term. Because if you think about it, n minus 1 means instead of taking the nth term, I'm looking at the nth minus 1 term. So instead of looking at the 10th term, I'm looking at the 9th term. So if I take the 9th term and I subtract 5, that'll give me the 10th term, right? It's kind of weird. And there's tons of different ways that this notation can be shown. So remember how we talked about how you can do the sub notation? You could also see different notation here. Now, we are only spending a week on this. I am not going to try and throw a bunch of different notations at you. I just wanted to make sure that I said that. If you see recursive rules written differently, it's not because Ms. Sherman lied to you. It's because there's just so many different ways to do it. All right, and so for recursive rule, for explicit rules, these ones are more like what we're used to. The key difference here is to remember that this starts at term 1. It doesn't start at term 0. And so it might be tempting to say that T of n equals 30 minus 5n, right? You have a starting value of 30, and then you subtract 5 each time. That feels good, but it's not right because the starting value in this, if I put in term 1, 5 times 1 would be 5, 30 minus 5 would be 25. Term 1 isn't 25. So I have to adjust everything for the fact that we start at 1 instead of starting at 0. So this is like the general format that'll always work, is if you take your term 1 and then you take your common difference or common multiplier, or not common multiplier, sorry, that's for geometric ones are totally different. This only works for arithmetic. So, and then that would be like your common difference, and that'll work. So like the term 1 is the 30, and the common difference is the -5, and then it always stays as an n-1 because we have to offset for the fact that it starts at 0, or that it starts at 1 instead of 0. All right, so I'm giving you a rule. I want you to write the sequence for this. First of all, is this an explicit rule or a recursive rule? Hopefully you agree this is a explicit rule because it doesn't have like the two different parts, right? I didn't define the first term and give you how it grows. I gave it to you all at once. So this is an explicit rule. Write down the first, I can't remember what I said, first 3 terms, 5 terms, something like that. All right, so hopefully you agree that the first term is going to be 100, since I've written it in the correct format with an n-1 here. And then the next term will be 125, 150, 175, 200. Now I could also use this to find the 20th term. To do that, I would say S of 20 equals 100 plus 25 times 20 minus 1. And then I would do that math. So that would give me that the 20th term is 575. So that's 2 different ways you can use an explicit rule. Let's try it with a recursive rule. All right, so here is the rule. I want you to write the first 5 terms, just like we did up above. All right, so we've been told the first term is 17. And then we've been told that each term is the previous term plus 10. So 17, 27, 37, 47, 57. Now, if I asked you to find A of 20, I could try plugging that in. A of 20 equals A of 20 minus 1, which is 19, plus 10. That's a true statement, but I don't know what A of 19 is. So I would have to count all the way up or do some other method of figuring out what that number would need to be, which essentially means like changing it into an explicit rule. Okay, and you're going to learn how to do that later, other classes, not this year. So if you're asked to do that, you would need to extend the sequence or just rewrite as an explicit rule, which wouldn't be too terribly hard for this one. I bet you could figure it out pretty easily. Okay, new sequence. S of n starts at -8, and then -2, -1/2, -1/8. I want you to write me a recursive rule, please. Give it a try. Fill in the missing numbers first. That helps you figure out what the pattern is. All right, so did you decide that we're dividing by 4 each time? So after -1/8, it would be -1/32, and then 32 times 4, -1/128, and -1/1 or 512. Very small numbers very quickly. Side note, is this ever going to turn positive? No, it's just going to keep getting closer and closer and closer to 0. All right, so for our recursive rule, we know that we need a term. So let's go crazy here. Let's say s of 2 equals -2, because it doesn't have to be the first term, right? I can pick any of these terms and I can use that. And then I'm also going to say that s of n equals s of n minus 1 divided by 4. So the previous term divided by 4 gives me the next term. All right, now explicit rules. This is something that we haven't really talked about, so I'm giving you this rule so that you've seen it, you're exposed to it, but I'm not going to be really expecting you to do a whole lot more with them. So our explicit rule, we always are going to have, this is written in the format of like y equals a times b to the power of n minus 1, or I shouldn't say y, I'll say s of n, where a is term 1 and b is the multiplier, or the common multiplier. And notice that since it was division, since it was divided by 4, my multiplier is a fraction, because I'm multiplying by 1/4 is the same as dividing by 4. And then it's always, just like in the arithmetic, it's always going to be an n minus 1, because we have to account for the fact that the first term is 1 instead of the first term being 0. And so we could try using that rule. Like if I asked you to calculate, like what is the 10th term? So s of 10, then you would do -8 times 1/4 to the 10 minus 1, which is 9. So in my calculator, I would plug in 1/4 to the power of 9, and then I would multiply that answer by -8. And it's going to give me like a super, super, super small decimal, so 0.25 to the power of 9. Ooh, scientific notation already. Times -8. Yee! Super tiny. Okay? I don't even want to write it down. It's really small. All right, finally, for your practice problem, I want you to tell me what are the first 5 terms of t when t of 1 equals 1 and t of n equals t of n minus 1 times 3. Good luck.